Module 3 Structural Geology and Rock Mechanics for Civil Engineering Department, 3rd semesters students. Course name is Engineering Geology and course code is 18CV36 Session 2. Faults. Fault is a displacement of two rock blocks either each other. These faults will be formed due to the brittle deformation. Parts of the faults. In the parts of the fault, there is hanging wall, footwall, fault plane, through, heave, and height. So, fault plane, a plane along which the rupture has actually taken place, or where one block is moved with respect to the other block, is known as fault plane. The angle between the fault plane and footwall is called, this BAC is called head, and horizontal distance between the movement of hanging wall and footwall, this is called heave, and vertical distance between hanging wall and footwall is called through. Here so types of faults. Fault can be divided into several different types depending on the direction of relative displacements. One is normal faults. The horizontal tensional stresses in brittle rocks and where the hanging wall block has moved down relative to the footwall. The hanging wall here moving down related to the footwall is called normal fault. The reverse fault, the horizontal compressional stresses in brittle rocks where the hanging wall block has moved up and related to the footwall block. Hanging wall will be moved up related to the footwall. So horst and graben, due to the tensional stress, the normal faults occur in a series with adjacent faults dipping in opposite directions. In such a cases, the downdraft blocks from grabens, this downdraft blocks is called graben faults, and uplift blocks is called horst. Fourth one, thrust fault. This thrust fault is a reverse fault where the dip of the fault is less than 45 degree. The thrust faults has the considerable displacement measuring hundreds of kilometers and can result in older strata overlying younger strata. So fifth one, strike slip faults are faults where the relative motion on the fault has taken place along a horizontal direction. Such fault result from shear stresses acting in the crust. So evidence of movement on faults or recognition of fault in the field. Fault involves rocks sliding past, may be left evidence of movement in the area of the fault plane. So first one, fault breccias means angular fragments in the fine grained matrix is if occurs in any areas, so we can analyze near to that area there is a fault. Then slick and slides. Along with fractures, rock fractures, there is a greenish type grizzling characters showing that slick and slides. So that also indicates the near that rock there may be fault zone. Third one, myelonite. Myelonite means it is a regional scale moving. Two blocks will be moving on in the fault plane. The minerals will be silicitising or fine grained silicitising or micaceous zones is indicates some faults that called myelonite zone. Then joints. A joint is a break or fracture of natural origin in the continuity of either a layer or a body of rock. Classification or types of joints. Non-systematic joints are irregular in form, spacing and orientation that cannot be readily grouped into distinctive through-going joint sets. There are in a joints there is no irregularities. So such a type of joints is called non-systematic joints. Second one, systematic joints are planar or parallel joints that can be traced for some distance and occur at regularly evenly spaced distances on the order centimeters, meters, tens of meters or even hundreds of meters. The joints will be forming in a planar or parallel. So there is systematic arrangements in the joints. It's called systematic joints. Based upon their orientation to the axial planes and axis of folds, the types of systematic joints are: longitudinal joints are roughly parallel to the fold axis. Cross joints which are approximately perpendicular to fold axis. Diagonal joints are typically occur as conjugate joint sets that trend oblique to the fold axis. Strike joints are trend parallel to the strikes of the axial planes of a fold. Cross strike joints are cut across the axial plane of a fold. The third one, columnar joints. These joints split a rock body into long prisms or columns. Typically such columns are hexagonal, although 3, 4 or 5 or 7 sided columns are relatively common. For example, in Malpe Beach we can observe this columnar joints. These joints will be developing in volcanic rocks near to the water bodies. Unconformity. An unconformity is defined as a surface of erosion or non-deposition occurring within a sequence of rocks. A simple definition, another one is there. The separation between two different formations is called also unconformities. Types of unconformities. First one, angular unconformity. It is characterized by different inclination and structural features above and below the surface of unconformities. This zigzag line is unconformity line. So below there is some holding structures in a rock. So above is horizontal rocks. So second one, disconformity. The beds lying below and above the surface of erosion or non-deposition are almost parallel. No fold or faulting or tilting of the strata. So third one, non-conformity. In a sequence of rocks composed of plutonic igneous rocks like granite, as older or underlying rocks, and sedimentary or volcanic rocks as the overlying younger or newer rocks. For this conformity, for example, in near Gajendragarh, the same setup is you can find in a rock. So fourth one, local unconformities. The unconformity is traceable only in a small area or in a few rock formation of a given areas. Fifth one, regional unconformity. The unconformity is traceable over a large area extending for hundreds of kilometers. It is conveniently called a regional unconformities. For example, in Saudati we can find this regional unconformities. That's also called as Eparchian unconformities. Thank you.